Hey, this is Mr. Barr, and this is Cube Roots and Ordering with a wonderful picture of a possum. I can work with the entire real number system. Why? There are a bunch of numbers besides 1, 2, and 3. I want to be able to use them all. I don't have anything super sassy to say about this one. We're going to look at cube roots and how to put irrational numbers into order from least to greatest. I'm going to do this one because it's one of those things that shows up on the state test. So let's start with our title and our notes. So start with your name at the top of your page. And cube roots and ordering. And we'll start with a couple squares. So 4 squared equals what? What's 4 squared? 4 squared equals 4 times 4, which is 16. What's 4 to the third? Well, 4 squared is 4 times 4. 4 to the third is 4 times 4 times 4. So that's how we cube a number. This is called 4 cubed. So it's called 4 cubed or 4 to the third. So that's some of your vocabulary there. So 4 squared, 4 to the cubed. 4 squared is 4 times 4. 4 cubed is 4 times 4 times 4. Now, working it backwards, I get cube roots. Notice a cube root has a little number here. It's called the index of 3, and it tells me I'm finding a cube root, not just a square root. So let's do a cube root. We're going to find the cube root of, did I have 64 there? 64. This is what it looks like. So now it's saying what times itself 3 times equals 64, which is 4. And that little 3 right there is called the index. I have an index of 3. The cube root of 64 is 4. So here are a bunch of other really popular cube roots. So let's get all of these into our notes also. So we have the cube root of 1 is 1. The cube root of 8 is 2. The cube root of 27 is 3. The cube root, I'm doing this 64, right? That's my next one, is 4. Let me get my index there. The cube root for 5, so whatever, it's 5 times 5 times 5, which is 125. The cube root of 125 is 5. The next one, whatever it's going to be, is going to be a 6, right? The cube root, is that 216? Oh, it's right there. Cube root of 216 is 6. Cube root of whatever it's going to be a 7. Is that 343? So there are the first 7 cube roots. And we can approximate cube roots in the same way that we approximated square roots. We just have to use the cube root negative, or cube root neighborhood. So let's approximate the cube root of 68. So let's find its neighborhood. So we have the cube root of 68. Well, I do know the cube root of 64, right? And I know the cube root of 64, 125. So this is somewhere between 4 and 5. And it's a lot closer to the 4, isn't it? Look how close it is down here. 64 to 68, it's really close. This is a big jump. So it's really close to the 4. So let's call it a 4.1. And that's how I approximate a cube root. Let's do another one. Do this one in our notes also. We'll approximate the cube root of 120. All right. Let me get those neighborhoods ready to go. 120, let's see. Well, I know 125. You know what? This is in the same neighborhood, isn't it? This is 125 and 64. It's between 4 and 5 again, isn't it? But this time it's a lot closer to the 5. So let's put it at about maybe a 4.9. Really close to a 4.9. All right, let's approximate this one right here. 2 plus the square root of 7. You know, I'm thinking, did I even... I feel like when I'm doing these, I'm not even sure I'm showing you what I did. I can't remember. Okay, here. There are the notes that go with these, in case I forgot to show you what I was writing. Sometimes I forget to bring my screen across. Let's divide it. These are two different problems. Okay, there are the notes in case I forgot to show you the notes. Let's do another one. Let's go with, let's approximate this. This, what's that? 2 plus the square root of 7. Square root of 7, man, I've done that one so many times. Square root of 7 is between 4 and, excuse me, it's between 2, let's do it. Just do it, Mr. Barr. Square root of 7. There's its neighborhood. It's between 2 and 3, and it's a little bit closer to the 3. Let's go with 2.6. So this is really 2 plus 2.6, which is 4.6. Okay, well, I just did that one. Let's approximate pi minus 2. Well, what's pi? Pi's about 3, isn't it? So when I see a pi, I'm just going to pretend like it's about a 3. So we just approximated that one. I keep adding things to this. Let's approximate the square root of 30 over 2. Square root of 30. Let's go into the neighborhood. These are the numbers in the neighborhood. Square root of 30. It's somewhere right in between 5 and 6. This one's about 5.5. It's actually a little bit closer to the 5, so maybe about a 5.4. So this is really 5.4 divided by 2, which is going to be 2.7. So I went into my neighborhood, and then I did the division by 2. Oh, okay, and now could we put all of those numbers on the number line? We could. Let's do that. You know what? You don't have to do this in your notes. I'll do it on my computer, though. Excuse me. Except I lost my pen. There it is. All right, so let's put these on a number line. So what did we say? 2.27 is... Oh, all right. So I'm going back in my notes. So we said this one was 4.6, right? We said this one was 1, and we said this one was 5.7. So let's put it on the number line. So this one right here, 4.6, would be right about here. This one would be right about there. And then 5.7 right about there. What else do I have for this lesson? Okay, same type of idea here. Let's see if we can do this one. All right, so the square root of 15, isn't that about, it's a little bit less than a 4, maybe a 3.9, so this is about a 3.9, isn't it? So I've got a 1 plus a 3.9. That takes me to a 4.9. Okay, so this is about a 4.9, right? About a 4.9. Right? Yeah. This is 2 times 3. Right, so this is 2 times pi, that's about a 6. So a 6 minus a 5, that takes it to about a 1. Yeah. 37, well that's just a little bit more than a 6, isn't it? Maybe that's about a 6.1 divided by 3. And that's going to be just a little bit bigger than a 2, isn't it? So let's call this maybe a 2.1. So just estimating things really fast. Let's put them on the number line. 4.9. 1, 2.1. So just some quick estimates and putting them on a number line. All right, that's it. I think. Yep, that's my last slide. Thank you for watching.